Good evening, everyone, and welcome to the third session on personal interview. Earlier, we had started studying artillery so that we can answer questions like, what do you know about Army other than ranks and commands? Which unit you would like to join and why? And also, what are the recent acquisitions, which we'll be studying in the subsequent sessions. So in the previous sessions, I had helped you understand about what is a charge, what is a primer, and what is the working mechanism of an impact fuse. Now, in today's session, we will continue our learning, our understanding about the different types of fuses which are used in artillery shells. What is their role? What is their working mechanism? And which fuse is used for which kind of a target or what kind of a purpose? I'm sure, friends, you must have heard about bunker buster bombs in recent times, especially which have been used on Iran last year, as well as even in recent times. Have you ever wondered how a bunker buster bomb works? Why it doesn't explode immediately upon hitting a bunker, and why it explodes only after penetrating till a certain distance? And what allows it to do that? That is where the role of fuse comes in. We'll study that in a while. Then another example which you might have seen in seen on YouTube or in movies is of illumination round. When the fighting is happening at night and there is complete darkness, enemy fires illumination round upon being fired after a certain time explodes and starts illuminating the battlefield below. So why it explodes only after a certain time after being fired? Again, there the role of fuse comes in. So let's start our today's session and try to understand what are the different types of fuses used in artillery and what is their working mechanism. So what are the different types of fuses in artillery shells? First, you have what is called the impact fuse or point detonating fuse. We have already studied it in the previous session. It detonates immediately upon hitting the target, commonly used for high explosive shells against structures, vehicles, or personnel. Then second is the delay fuse. Now, this is the kind of fuse which is used in bunker buster bombs. This fuse is designed in such a way that it does not allow the shell to explode immediately upon hitting the target. It allows the shell to penetrate the target to a certain distance, and only after that the shell explodes. So this is specially used when you're trying to hit or destroy a fortified concretized bunker, or for instance a heavily armored vehicle like a tank. That is where delay fuse comes in. Detonates a short time after impact, allows the shell to penetrate walls, bunkers, or armor before exploding. Then third is proximity fuse. Now the name itself makes things clear. It's proximity fuse, which means it is designed in such a way that it triggers the explosion of the shell when the shell gets close to the target, and not necessary that it will make a physical contact or hit the target. Now this proximity fuse was designed and invented during the Second World War, when hitting a fast flying enemy aircraft, making a physical contact used to be almost impossible. That's why they designed this proximity fuse, so that if there is a aircraft or any other object which is flying at a very high speed, and you want to maximize the opportunity of causing damage to it even when there is no physical contact, that is where proximity fuse comes in. We'll study this in detail. We'll study delay fuse also in detail. It uses radars or sensors to detonate when the shell comes close to the target. Now here, you might have seen radars on television which are very big. Now here, it is not those radars we are talking about. These are miniature radars, hardly weighing around 50 to 100 grams in weight. And these miniature radars are having a transmitter and a receiver. The entire working mechanism of this proximity fuse we'll study in detail in a while. Effective against aircraft, drones, or troops in open areas. Then time fuse. The kind of fuse which is used in illumination round. When you want the explosion to happen after a certain predefined time, of the shell being launched. That is when the time fuse comes in. The time is set manually before firing to detonate after a specific time in flight. The illumination round explodes and starts illuminating the battlefield below only after a certain time of being fired. Then used for airburst missions, illumination shells, or smoke shells. Electronic or multi-option fuse. This is a multi-option fuse, modern programmable fuse that can be set to impact or delay or proximity mode. Provides flexibility for different battlefield conditions with a single fuse type. Then there is something called base fuse located at the rear base of the shell instead of the nose. Most of the times the fuse is fitted at the nose, not really at the base, but in very rare scenarios you have it fitted at the base, and that is the base fuse, often used in armor piercing shells to ensure detonation after penetration. Conclusion: a fuse is the brain of an artillery shell, deciding when and how it explodes. Different fuse types give commanders tactical options, from immediate impact blasts to air bursts or delayed penetrations. So fuse is what decides when and how the shell will explode. Now let's study proximity, time delay, and time fuse in detail. First, we'll understand what is a proximity fuse. As I have already explained, for example, when you want to maximize the possibility of damaging a fast flying aircraft, you know that it will be difficult to hit it directly. It will be difficult for the shell to make a direct contact with the aircraft because it is flying at a high speed. That is when you use proximity fuse, so that the moment it gets close enough to the aircraft, even if it is not able to make a physical contact, it will initiate the explosion of the shell, thereby causing a lot of physical damage to the aircraft. That is where proximity fuse comes in. A proximity fuse in artillery is an advanced fuse that detonates a shell when it comes within a set distance of a target, using radio waves, radar, or other sensors to detect proximity rather than requiring direct impact. Now I'm showing you all these important points on screen so that if you're really serious about preparing for interview, you can make notes during your free time. Now, this is where you are able to see all the components of a fuse, that is a proximity fuse. You'll not be able to read everything because it's very small, but I'll help you understand where the transmitter and receiver, the miniature radar, is fitted, and it is towards the tip, towards the tip of the entire system. Now here, I'll just highlight it once again. You'll be able to see this is the transmitter and receiver. Now, how it works is, for the radar to work, it needs electrical energy, it needs electricity. And that is why there is a battery fitted in the fuse. But when does it turn on and how does it turn on? It turns on only after the shell is fired. It is not on all the time. It is not on 24/7. Otherwise, the battery will get exhausted. So, if you remember, I had explained to you about how there is a disc which prevents the striking pin from hitting the detonator in the safety mode. After the shell is fired, in cases of impact fuse, that is, after the shell is fired, due to the acceleration forces and the centrifugal forces, the disc gets removed from its place, thereby opening the way for the for the striking pin to hit the detonator. The same principle, same methodology is used even to activate the radar. Now here you will be able to see in the circle I have pointed out that the electric system during safety mode is closed. It is not working. Okay, it's a disconnected circuit. When the shell gets fired, just like how in the impact fuse, the disc, which is standing as a barrier between the striking pin and the detonator, gets removed, the same way, the object which is there, which is ensuring that the circuit doesn't become live, gets removed automatically, and then this circuit becomes activated, and that's how the radar turns on and starts emitting signal. Now, in this particular image, you will be able to see that the circuit is completely on, it is connected, and that's how the radar starts working. Now, frequency shift occurs. I'm sure if you have studied science, if you have good understanding of how frequency works, there is something called Doppler effect. What is Doppler effect? Let's say, if the shell is moving closer to the target, the signal which it is emitting when it is bouncing back, if it is getting closer to the target, if the distance is decreasing, the frequency of the returning signal will increase, it will be higher. Whereas if the target is growing distant, it is going away, and the distance between the target and the shell is increasing, then the returning frequency, the returning signal will be of a lower frequency. So that is what is called Doppler effect. Okay, and based on this, the shell is able to understand, the shell's miniature radar is able to understand whether it is close enough or not to the target. So if the shell is moving toward the target, the reflected waves return at a slightly higher frequency than what was transmitted. If moving away, they return at a slightly lower frequency. What is the weight of this miniature radar or radio? I've already explained it. It's around 50 to 100 grams. Exceptionally, it can be slightly higher or lower as well. Now, what is the frequency at which this miniature radar in the artillery shell or in the shell operates? Now, generally, there are two frequencies, two bands at which it operates. One is the X band, that is between 8 to 12 gigahertz, and one is the K band, that is between 18 to 27 gigahertz. So, generally, see, whatever I'm teaching you, it's applicable for majority of the equipment in this particular category, but there can be exceptions also. You always need to ensure that, when you are discussing it in front of the IO. Okay, so generally it is X band or K band, 18 to 12, 8 to 12 gigahertz or 18 to 27 gigahertz. Now, what is the general range? Proximity fuses are designed to detonate within a few meters of the target. So what is the range at which they tend to explode? Typically, effective distances are between 1 to 10 meters, depending on shell type and target. Now we will see what is the different range, different ranges at which it tends to explode depending on what the target is. So for instance, if you are targeting an aircraft, the detonation usually occurs at around 3 to 7 meters from the aircraft. So it is there, this distance ensures that maximum damage is caused to the aircraft. This ensures the fragmentation cloud intersects the fuselage or wings for maximum damage. Fuselage is the central tubular body of any aircraft. Too close risks passing through without optimal fragment spread. Too far reduces lethality. Then against ground troops, shells are set to explode at 2 to 5 meters above ground. This height maximizes fragment dispersion over a wide area, increasing casualty radius. You might have seen, if you have seen Lakshya, that movie, in one of the scenes, if you remember, this kind of a fragmentation warhead explodes above the Indian troops, and the fragments penetrate the bodies of many soldiers. So this is what we are referring to here. Against ground troops, it explodes at around 2 to 5 meters above ground, and that's why the fragment spreads over a wide area and causing maximum damage to the personnel on the ground. Lower bursts risks fragments being absorbed by soil. Higher bursts reduce density on target. Against armored vehicles, proximity fuses may trigger at 0.5 to 2 meters above or beside the vehicle. This allows fragments or shaped charges to strike vulnerable surfaces like hatches, optics, or tracks. What is a shaped charge? We'll be studying in one of the subsequent sessions. Today, we are only going to restrict our discussion around fuse and all the technology related to fuse. Now, when it comes to naval targets like ships or missiles, detonation distances are typically 2 to 10 meters from hulls or missile bodies. Ensures blast and fragments penetrate superstructures or critical systems without requiring a direct hit. That was all about proximity fuse. Now let us study time delay fuse. Now, how does time delay fuse work? I'll help you understand in a very simple manner. See, when it comes to time delay fuse, a very simple technique is used. They add extra element of pyrotechnic charge. During Diwali, you all must have exploded crackers. So for instance, if you have ever exploded a Sutli bomb or a Lakshmi bomb, that bomb has a thin wire kind of a thing, which is completely having, sort of explosive material in it, right? Okay, inflammable material rather than explosive. So pyrotechnic charge is something of a similar nature. It's a tubular kind of a thing, okay, capsule or a tube of explosive material. It is added so that it will take extra time to burn. And because of that extra time, the shell will not explode instantly after hitting the target, and it will explode after some time. Now, this some time is not hours or minutes, it is few microseconds. We'll study about it in detail. So let us understand about the working mechanism of a time delay fuse. A definition: a delay fuse is a type of artillery fuse designed to detonate the shell after a short, controlled interval following impact rather than instantaneously. The easiest example to understand is hitting a concretized underground bunker. You don't want the shell to explode immediately after impact, because that ways the people and the equipment inside will not get damaged, they will not suffer any harm, whereas your purpose of hitting that target is to cause maximum damage to the people or the equipment inside. That's when you use a time delay fuse, so that the shell is able to penetrate the concretized wall and then explode inside, killing the people inside or damaging the equipment inside. Then the delay is usually fractions of a second, allowing the shell to penetrate target before exploding. So it is fractions of a second, okay? Not hours or minutes, just microseconds, fractions of a second. Then mechanism of action: on impact, the striker hits the detonator, initiating the explosive train. Instead of immediately transferring energy to the booster, the fuse includes a delay element, often a small pyrotechnic charge. So it's like adding additional tube of this pyrotechnic charge between the detonator and the booster charge. So it takes little time to burn, little extra time, and that is what gives it that necessary extra time to cause that delay and then explode after penetrating the concrete wall. So this delay element burns for a preset time, milliseconds to a fraction of a second. After the delay burns through, it ignites the booster, which then detonates the main charge. The shell explodes after penetrating the target material. Delay element composition: what is this delay element made up of? Typically made up of slow burning pyrotechnic mixtures like lead stiphanate, barium nitrate, or antimony sulfide, designed to be reliable, consistent, and resistant to accidental ignition, calibrated to provide precise timing, commonly 0.025 to 0.15 seconds in artillery fuses. So you can understand, delay doesn't mean hours or minutes, it's 0.025 to 0.015 seconds. Now, delay options can range from instantaneous to fractions of a second. Some advanced fuses allow longer delays for specialized applications like deep penetration or demolition, especially the bunker buster bombs which the Americans used in June last year. They were having this element of longer delay. In the subsequent sessions, I'll be trying to take sessions on specific ammunition, weapons, bombs, and in that you will understand everything in detail. Settings are often adjusted by rotating a dial or inserting a selector pin or using electronic programming. Now here you can see on this particular fuse, on the top, you will see the dials are there. You can rotate those dials and accordingly select, what kind of time delay you want. Now when you rotate this dial, inside how it works is it reduces or increases the size of that tube or that capsule of the pyrotechnic charge, and that's how the time gets increased or decreased. Okay. Typical delay durations: delay fuses usually range from 0.15 second to about 0.015 seconds to about 0.15 seconds. Very short delays, 0.015 to 0.025 seconds, are used for thin armor or light fortifications. Medium delays, that is between 0.05 to 0.1 seconds, are used for thicker armor, concrete, or ship hulls. Longer delays, that is more than 0.1 seconds, are rare but may be used for deep penetration or demolition shells. Now, relation to shell velocity. Now, you must be wondering, in 0.05 seconds, how much it will penetrate, how much distance it will penetrate. In 0.06 seconds, how much distance it will penetrate. When you talk in front of the interviewing officer about these topics, you should have precise information and you should be very good with numbers. So please understand everything in detail here. I'm trying to give you as much information as is possible and will really help you shine in the interview. Now, artillery shells generally travel at extremely high speeds, somewhere around 600 to 900 meters per second for many calibers. Even a 0.025-second delay allows the shell to move 15 to 20 meters in free flight, but inside a target, penetration depth is much less due to resistance. This delay is calibrated so the shell, it detonates inside the target material, not after passing through completely. If it passes through completely, comes out from the other side, then of course there is no use. So that is why everything is taken into consideration when this fuse is designed and when the shell is fired. Penetration distance inside target, very, very important. In solid materials like armor, concrete, or soil, the shell slows rapidly. A delay of 0.025 to 0.05 seconds typically corresponds to penetration depths of a few centimeters to a meter, depending on shell type and target hardness. Longer delays allow deeper penetration before detonation, ensuring maximum internal damage. That was all about time delay fuse. Let us now study time fuse. Now, as I said earlier, that for instance, if you fire an illumination round, it is supposed to explode after a certain time after being fired. So how does that work? All right. Definition. A time fuse is a fuse designed to detonate an artillery shell after a predetermined interval of time following firing. Unlike impact or proximity fuses, it does not rely on striking a target or sensing distance. Purpose: used to create air bursts above ground troops for maximum fragmentation effect. Employed in illumination rounds, detonating at altitude to release flares. Applied in smoke shells, bursting at a set height to spread smoke. Historically used in anti-aircraft fire before proximity fuses were developed. Even today, guys, when anti-aircraft rounds are fired, even if they don't hit the target, they explode after traveling to a certain height, or after a certain time of being fired. Why? Because when you fire an anti-aircraft round, you don't want that if it is not hitting the target, that is the aircraft, enemy aircraft, it should go and fall on some civilian area and kill people that way. That's why the mechanism of anti-aircraft rounds is such that if it is not able to hit the target after traveling till a certain time and till a certain height, it should destroy itself. It has a self-destructive mechanism, and even there this time fuse is having a critical role. Now, mechanism of operation: the fuse contains a pyrotechnic delay train, slow burning powder, just like time delay. Before firing, the gun crew sets the fuse to the desired time interval using a graduated scale. When the shell is fired, the propellant gases ignite the fuse's time element. The delay composition burns steadily for the set duration. After the burn completes, it ignites the detonator, then the booster, and then the main charge. The shell explodes at a chosen time, ideally at a specific altitude or distance. Now that is the working mechanism. Now adjustment process, how do you adjust it to that kind of required time? So soldiers use a fuse setter tool to rotate or cut the fuse to the required time setting. I'll show you in a while what this fuse setter tool is and how it is used. We'll be able to see photographs, and we already saw about how there are dials on a time delay fuse to adjust setting as per your requirement. The same is applicable even for time fuse. The setting determines how much of the pyrotechnic train is exposed to ignition. Longer exposed strain is equal to longer burn is equal to longer delay. Shorter exposed strain is equal to shorter burn and shortened delay. Now here, this is also a time fuse. Here on the top, you will be able to see on the tip of it, that there are dials which you can rotate, and accordingly you can adjust the timing as per your requirement. Now here also, this is also a time fuse. You can see that in the conical structure, there are screws which you can move, and accordingly you can adjust the length of that pyrotechnic charge inside, and thereby you can adjust the time. Now here you can see that the soldier, this is a US Army photograph, of course. Soldier is using a fuse setter tool to adjust the fuse on the shell. Now this is what a fuse setter tool looks like. Typical time ranges can be set from fractions of a second up to 30 seconds, depending on shell type. Short times for close range air bursts, longer times for illumination or distant targets. Advantages: provides controlled detonation timing without needing direct impact. Effective for area coverage and psychological effect. Versatile for multiple shell types like high explosive, smoke, and illumination. All right. High explosive, I'm sorry, in high explosive, generally this is not used. It's mainly used in smoke and illumination. Conclusion: a time fuse works by burning a preset pyrotechnic delay after firing, then triggering detonation at the chosen moment, enabling airbursts or special effects at specific ranges. How propellant gases ignite the fuse time element in artillery shells, how this time element gets ignited. This kind of a fuse has holes or vents in it, which are there so that the charge, when it ignites and it starts releasing high pressure gases, those gases will be able to reach, the inside of the fuse. And because of those gases, this pyrotechnic delay, this time delay ignites, time element ignites. Location of the time element. The time fuse is fitted at the nose of the shell. Inside the fuse, there is a pyrotechnic delay composition, a slow burning powder train. This composition must be ignited at the moment of firing or to start the countdown. Role of propellant gases. When the shell is fired, the propellant charge in the gun chamber burns rapidly, producing hot gases and high pressure. These gases not only push the shell forward, but also serve to ignite the fuse's time element. The fuse has a small ignition channel or vent at its base. As the shell is propelled forward, a portion of the hot propellant gases flows into this channel. The gases ignite a primer or igniter pellet located at the bottom of the fuse. The igniter pellet produces a flame. This flame is directed into the pyrotechnic delay composition. The delay composition begins burning at a controlled rate. The pyrotechnic mixture is formulated to burn slowly and evenly, unlike the fast burning propellant. The length of the exposed train set by the soldier before firing determines how long it burns before reaching the detonator. Once the delay composition finishes burning, it ignites the detonator. The detonator sets off the booster, which then detonates the main charge at the chosen time. So that is how this time fuse works. The fuse design, safety and reliability. The fuse design ensures that ignition of the time element only occurs when the shell is fired, not during handling. The ignition vent is positioned so that only the high pressure propellant gases in the barrel can activate it. This guarantees synchronization between firing and the start of the timing sequence. To summarize, the hot propellant gases from the gun ignite a small primer inside the fuse, which lights the pyrotechnic delay train. That train burns for the set time before triggering detonation. So that brings us to the end of today's session. I'm sure you found the session useful. Please like it. Please share it with all your friends who are preparing for SSB, and encourage everyone you know who are preparing for SSB, who is preparing for SSB, to subscribe to our channel. Tomorrow, we'll have a VAT session on the word beggar. So please don't miss it. It will be very useful for your psychology purpose. On Monday, we will study different types of shells which are used in artillery. It will be an extremely useful as well as very interesting session. Make sure you don't miss out on it. And that brings us to the end of today's session. I'll stop the video here. Please take very good care of yourself and enjoy the rest of your evening. Good night. Bye-bye.